Well, good morning, everybody. I think it's still morning. Yes, we're still morning. What day is it? Where are we? I don't know anymore. But it's been such a wonderful couple of days here that I'm just lost in a sea of fantasy about genetic genealogy. And so great to be here with so many citizen scientists, like-minded people who share the same addiction as I do.
Hours of happiness.
Hours of happiness, absolutely hours of happiness. Somebody was in Southern California. Well, I'm going to talk to you today about an Irish approach to assessing autosomal DNA matches. Now, what that actually means is I'm really just going to tell you about my experience of using autosomal DNA coming from Ireland. I'm trying to apply a lot of the methodologies that we have been hearing about over the last couple of days, and to highlight some of the challenges that I have faced personally with my Irish genealogy, my Irish genetic genealogy, in the hope that a lot of it will be of general relevance to you, and that it will help particularly those of you who have the same kind of problems in your own particular situation. So just to remind you about what our goal is with autosomal DNA, it's to confirm known or suspected relationships, it's to connect with distant cousins, it's to use what they know about their family tree to break through brick walls in ours. And to a certain extent, it's also to determine our ethnic makeup, but I won't be discussing that to any great extent today. Now, just to remind you about autosomal DNA, we have these 22 pairs of autosomes which contain about 95% of the chromosomal DNA. The other 5% is in the X and Y chromosomes. The X chromosome is frequently attached to the autosomes and reported in the same batch, as you probably know. And in terms of my autosomal DNA in my family tree, I've taken the test. That's brought me back, or at least it allows me a reach of about 5 to 7 generations, about 1765 or so. I've also tested my dad, which allows me to go back an extra generation, and I've tested my aunt, which allows me to go back an extra generation. So all in all, my reach back into the past goes back to about 1700. There are two approaches to autosomal DNA testing. You can either ask a specific question. I'm sure we're related to that crowd and they probably have money. So want to establish that connection. In that case, you and someone else have to take the test. Or you can go on a fishing trip, in which case you just put your DNA into the gene pool and see what you can catch. And you only need to take the test in that particular situation. But to illustrate the first one, how it addresses a specific question, I'll run briefly through the mystery of the wedding memento. And this was a wedding memento that fell out of my dad's grandfather's papers a couple of years ago when he was just shuffling through them. And he thought it was a bookmark, but he picked it up. And it was a wedding memento of David Patterson and Ruby Kay Gleason. We discovered it later was Ruby Kathleen Gleason. And they were married at Thargo Minda on the 23rd of March, 1893. And this was very, very interesting. My dad contacted his first cousin and said, you know, is this person related to us? And she said, no, Ruby Kathleen, no, not one of ours. Put her in the shoebox, put her under the bed. And I thought, well, hold on a second. I wasn't quite so happy about relegating her to the shoebox of obscurity, as I call it. So I took up the challenge of finding out who she was and where she was from. The first thing to do was to Google Thargo Minda. Oh, probably a townland in Laois. They have weird names, you know. But it actually turned out it was in the middle of the Australian desert. Surrounded by man-eating koalas, poisonous snakes, murderers, teetering on the brink of nothing. Now I should add, this is a modern map. So this was an intriguing mystery. I thought, what the heck? is a wedding memento from the desert in Australia doing halfway around the world in Dublin. So I was able to find her marriage certificate and her death certificate, and on both certificates it said her parents were John and Anne Gleason. I thought fantastic, because my great-great-grandparents were John and Anne Gleason. And it said she was born in Longstone. Oh, bingo, because that's the townland right beside Killiscully and Tralee, where all of my great-grandfather's siblings were born. She said her father was a hotel keeper or farmer. Mine was a laborer. He never set foot in a hotel. She was born around about 1872. That was 1868, 1872, 1877 for my grandfather and his siblings. Maybe the Kathleen became Catherine over here became Kathleen. Would that be possible? Tantalizing possibility. Ruby Kathleen went to Australia in 1886 according to her death certificate, and that would have corresponded with the death of my great-great-grandfather in 1885, family thrown on desperate circumstances, everybody has to emigrate. What else? Oh yes, we did have some family lore that Timothy and Winifred went off to Australia, and Winifred had a daughter who was a concert pianist or a singer. Well, that was all we knew. That was all that I had. So what I did was I filled out Ruby Kathleen's tree as best as I could, put it up on Genes Reunited, checked it every 6 months, and 2 years later, I found somebody who was able to put me in touch with her grandson. And he was in his 80s. And Alan was living in Sydney, and we struck up an email conversation. I found out that she had an uncle and aunt that she used to go and visit in Sydney. She also had a brother who went off to the US and became a famous baseball star. And he sent them a watch with an inscription on the back of it. And they can't find it. So the other interesting thing was that Ruby had a daughter, Alma, who was a musician and excelled at the violin. So there were all of these interesting parallels, but there was nothing there that you could really say, hold on, these people are the same people. John and Anne Gleason are the same John and Anne Gleason. So I asked Alan, would he be interested in doing a DNA test? And here's my great-grandfather Martin, and there's Ruby Kathleen, and he said, yes, I would. Now, if the documentary evidence was correct, it would suggest that Martin and Ruby were brother and sister. Jack and Ivy Myrtle May would have been first cousins, and my dad and Alan would have been second cousins, and they should share, on average, 3% of their DNA with a range of 1.3 to 4.3. The results came back, 2.6%, right on the mark. Okay, so that suggested very strongly that they were second cousins. My own came back and it showed me as sharing 1.5, which again is right on the average that you'd expect for the population. So all of this served to tell us that we, Dad and Alan, are definitely genetically related. The best fit is second cousins. It's confirmed the suspected relationship with 99% probability. You can't be 100% sure. There are still unanswered questions. Which of the sisters became Ruby Kathleen? Was it Catherine became Kathleen? Or was there another sister that we don't even know about? But Ruby Kathleen has been saved from this shoebox of obscurity. Hey, so, and we have new cousins in Australia. They have cousins over in Ireland. I'm going to meet them actually when I go back to London next week because they're coming over on a visit. Sadly, Alan passed away in October of last year. But they've just had their first grandchild. Alan's son has just had their first grandchild. So, you know, the life goes on. But it also points to the fact that it's important to catch people while they're still alive. So autosomal DNA can answer specific questions. It can confirm two people are related. It can help focus your research and can be a useful extra tool. And at the end of this exercise, it's basically telling us you're on the right track. Take out the shoebox. She doesn't belong there. Do your documentary research now and find out, why did she change her name to Ruby? So that's the kind of questions that we are going to be asking ourselves.
My
Michelle.
grandmother's name was Winifred, and she changed her name. So I think it's your Winifred.
Really?
She didn't like her name.
Winifred's not a great name, really.
But Ruby is very cool.
It is cool. I wasn't sure whether Ruby was something to do with her red hair. That's the latest thing. It could be red hair. So, but that kind of research goes on. If you have any ideas, let me know. So that's the first thing. That's the specific question. I'm using autosomal DNA to answer a specific question. I'm going to put on my clock because I know that I tend to talk an awfully long time, and I will likely run over if I'm not controlled. So, where's it gone? Oh, I'll find it anyway. So, the fishing trip. This is the second. This is the second option. If you want to do a fishing trip, what do you actually do? And you can test your autosomal DNA with 3 different companies. You can also upload it to Gedmatch. Everybody is encouraged to do so. So that way you can compare your DNA with people who have uploaded their DNA from other companies. First big question, first challenge, where are the Irish? Where are the Irish? Which database will give me the most success? Well, I have got 360 matches on family tree DNA. I have got 1,343 matches on 23andMe. And I have 10,700 matches on Ancestral. Well, I'm dancing for joy. Or am I? The percent of people who are potentially US is about 70% in the Ancestry, in the family tree DNA database, about 90% in 23andMe, and about 99% in Ancestry, because it's not sold outside the US, it's not sold in Ireland. 23andMe have an $80 postage and packaging to get it to Ireland, so probably more people are going to be in the family tree DNA database. But having said that, there's probably more Irish Americans in the other two, so it's kind of a balance. Which is going to give me, as a kind of native Irish person, the best option? Well, I looked at my first to third, second to fourth, third to fifth, and greater than fourth and greater than fifth cousin matches, and I have no close matches on family tree DNA. I've got 5, which is 2% second to fourth cousins, 8% third to fifth, 15% greater than fourth, most of them 75% greater than fifth. Okay, how about 23andMe? I have 1 second to fourth cousin. How about Ancestry? Okay, I have nothing on Ancestry. I have 0.1% of them are greater than fourth, and 10,691 are fifth or greater. So it would seem that most Irish Americans of Irish ancestors who emigrated in the early 1800s, they're going to be the more distant matches, and that's what we're seeing here, also seeing in 23andMe to an extent. So for me, perhaps, and this is Gedmatch as well, I only have, there's 1,500 matches. I reckon about 86% are non-US in Gedmatch, just that, and that's a very crude estimate. And I have about 82 second to fourth cousins in Gedmatch, and you can see that 28% of Gedmatch comes from family tree DNA. I'll come back to that in a while. So where are the Irish? Well, certainly upload your DNA to Gedmatch. That's the solution. Test with all 3 companies, with maybe family tree DNA first and then the others afterwards. Yes, if you're native Irish, family tree DNA. If you're Irish American, do you want to connect within the US? Or do you want to connect back to Ireland? So that's the question you have to ask yourself. If it's back to Ireland, then maybe family tree DNA is where you should be to maximize your chances of closer matches. Hot on the heels of this first challenge is the fact that we all know that most matches are distant, and most matches are further back than what are predicted, especially if you have cousins intermarrying, and especially perhaps if you're this would be common in isolated rural communities, that you might get inadvertent cousin matches, something my dad refers to as socially acceptable inbreeding. And this would be quite frequently indicated on the church records. If cousins were getting married, it would tell you the degree of relationship between the two of them. So that's very, very useful to know if you've got two Gleasons marrying each other. The trouble is that the further back you go, there is less documentary evidence, and there's less chance of breaking through brick walls. A big problem in Ireland, because we have had a series of fires. 1711, 1758 destroyed a huge amount of historically relevant documentation. 1861 and 1871 censuses were destroyed by mistake, a clerical mistake. 1914 war efforts saw the pulping of the remaining 1861 to 1891 censuses. And then in 1921, we had a fire in the Custom House which destroyed tax returns, which nobody thought we'd greatly miss, but they would have been quite useful from a genealogical point of view. But the big one, of course, was the Public Record Office fire in 1922, which destroyed the Public Records Office in the Four Courts in Dublin, and in the space of a couple of seconds, 800 years of Irish history went up in smoke. So we lost a huge amount in that fire. We lost census records of pre-famine Ireland. Who here has got ancestors who came over at or about the time of the famine? 1840, 1845. Your ancestors were there. They were there. We've got transportation records back to the 1700s, often containing petitions from the prisoners themselves. Lost. Military records with details of the local yeomanry going back to the 1700s. Church of Ireland parish records, which went back into the 1600s. And they would have been so rich, because many of us who are raised as Catholic, you go back far enough, you find that you are Church of Ireland as well. Many wills dating back to the 1500s. Land transfer records from the 1600s, which would have had tons of information on it. Church court records dating back to the 1200s, with details of criminal and civil cases, and even ecclesiastical records such as the deeds of Christ Church, which went back to 1174. So we lost a huge amount in that fire, and that really creates problems. Now, fragments do survive. So, for example, here we have Thomas Smith. Any Smiths in the audience? Could be one of yours. I mean, how many Thomas Smiths can there be? And this Thomas Smith was 104 in 1821, indicating he was born in 1717. So the person who owns this particular ancestor is blessed. You're going back to the early 1700s, and in the actual record itself, it shows you that Thomas, aged 104, had a young wife, aged 60. They had a daughter, aged 27, and a grandson, aged 2 years old. So that is a godsend for somebody, but unfortunately not for the majority of us, because we have our brick walls at 1800 to 1850. And that's after exhausting the usual sources such as family lore, the letters, the family Bible, the 1901 and 1911 census, Griffith's valuation of the mid-1800s, with the cancellation books, really, really useful thereafter, going all the way up to the 1930s. We have birth, marriage, and death records with civil registration starting in 1865. We've got church records that go back to the 1800s. We have got collaboration with online researchers on Ancestry, Genes Reunited, MyHeritage, RootsWeb, the newspapers coming online and really filling out that 1800 to 1850 timeline. Glasnevin records, superb for anybody in Dublin, but a brick wall at 1800, 1830 for the majority of people with Irish ancestry. I've used yDNA on my Spearin line to break through and take me back to the early 1700s, late 1600s. And that has really been a godsend. It's pointed me in the direction of further documentary research. So what are the solutions then for the fact that most matches are distant, most matches are further back than predicted, there's a relative lack of records before 1800, and we have brick walls at 1800 to 1850. We need to characterize our brick walls as best we can. We need to focus on our closest matches first, and it's difficult in Ireland to go beyond third to fifth cousins. yDNA surname projects may be a useful anchor, and we should encourage project administrators to add Family Finder results to their Y-DNA projects or accept Family Finder results into their projects. We also need to upskill Y-DNA project admins to deal with autosomal DNA, because that crowd can be very cliquish. They like Y-DNA and very little else. Sometimes. So that's an interesting possible way forward to the future. Now, in order to characterize your brick wall, what do you do when your most distant known ancestor is from Ireland and you know nothing else about them? Well, there's various things you can do. You can look at surname distribution maps, and here's a variety of them. And I should mention that this presentation will be available as a PDF on Tim's link. You will click on the links and they will take you to the website. Okay, so those links are active. Look at the surname distribution maps and see where your surname came from. If you've got several surnames, see where they intersect. Okay, that even narrows it down even further. You can use autosomal DNA to see if you actually match people from a particular area of Ireland, which could help focus your documentary research. Surname Y-DNA studies as well may be localized to a particular area, focus your research there. Match mapping you can do yourself, or you can use Irish Origins or Genetic Homeland to do it for you, or to help you with it. And that uses not just the overlap of surnames, but the overlap of genetic data to actually focus in on things. And there's a presentation that I explain it in greater depth, and they're on YouTube, and you can click on these links here. The People of the British Isles project is particularly interesting because they recruited 8,000 people with 4 grandparents from the same general area, about a radius of about 30 to 60 miles. Of those 8,000 people, they analyzed the DNA and they were able to isolate 29 distinct genetic communities in England. That means that in the next 12 to 18 months, you will be able to compare your autosomal DNA to this publicly available autosomal DNA and find out that 10% of your relatives came from Devon, 30% came from North Wales, and 50% came from North Orkney. So this is biogeographical analysis on a much more precise scale. And they reckon between the next 12 to 18 months, it should be publicly available for you to compare your autosomal DNA to this data. That will hopefully be available in 2016. Good news is that Ireland is joining in, and the Irish DNA Atlas project is apparently now being incorporated into the People of the British Isles project. They have a slightly more strict criteria, 8 great-grandparents from the same general area, and they only have 100 people recruited so far. So recruitment is going slowly, but is the better quality of their sample, is that going to offset the lower numbers? Time will tell. I would say we're not likely to get a similar kind of comparative capabilities until about 2020. Now, the other way to characterize your brick wall, if you do find your ancestors in Ireland, are to look up birth, marriage, and death records for addresses and locations of where they actually were. Get the witnesses at their wedding, the witnesses at their baptism of their children. These are likely to be the brothers and sisters whom your matches will have descended from. So important to find out these brothers and sisters. Add the weddings of their children, informants on death certificates, and location. You can get this from birth, marriage, and death records, and the whole of Ireland is covered by these websites. Roots Ireland and Irish Genealogy. So Roots Ireland covers all the bits in green. Carlo is coming online soon. Irish Genealogy covers the rest. And then in terms of the civil records, Family Search has the index available online, and then you can order the individual certificates via the LDS Centre or via the General Registry Office in Ireland online. I have a YouTube video about that as well. You can click there and get further details if you want to take that further. The big problem is, where do you put these clues in your tree on Ancestry or wherever it is? What I tend to do, if I identify possible siblings from the list of witnesses, I will put them as a query brother or query sister on my actual tree. But I'll have a question mark beside that name because I don't know whether that person is real or not. And I know that somebody's going to copy it and remove that question mark and say, oh, we definitely was established that these people were related because somebody put the tree up on Ancestry. So that's always going to be a challenge. And it would be great, actually, if Ancestry had a facility where you could indicate that a relative was a putative or potential relative. And that might stop a lot of people from copying it. Maybe you put it in a box that flashes red all the time. Other witnesses I put in the description field of the birth location, in the location field. I add Word documents to the media gallery for each of these brick walls on the maternal side and each of these brick walls on the paternal side. So that way somebody looking for them can download further information about my brick walls all in one document. Another big challenge, and this is for the entire community and not just people doing Irish research, is what is a match, or more specifically, when is a match not a match? Now, a match is someone who has an identical segment of DNA compared to you. Okay, that's a relatively simple, if not simplistic, term or definition. It implies that you both share a common ancestor. And I'm going to talk a little bit about chromosome 21, or any chromosome. Here we have your typical chromosome. The nucleotide base is GCAT. The G binds to C, A to T. And because they are mirror images, we only need to read one of the strands of the double helix. And what we do when we put it through the Illumina or the Matrix machine, we're comparing our two copies of DNA of this particular chromosome with the other person's two copies of that particular chromosome. And the call for position 1 will not be a single base, but a double base. A base here and a base up here. Position 2, a base here, a base up here. Position 3, and so on. So we get the two bases at a particular position on both copies of our chromosome 21. And we're comparing that to the other person's two copies of chromosome 21. And they get a call of TT, CT, GA, ACA. And some of these are going to be identical. Some of these are going to be non-identical, and some of these will be half identical. The C is half identical with the C here. The AG is identical with the GA here, even though it's reversed. GG is not identical at all with CT. So that's why you get these regions, and on Gedmatch they portray it quite nicely as these yellow bits, the green bits, and the red bits. And that's what they refer to. Now, so to summarize, for each chromosome, we're comparing your two copies with your match's two copies. Half identical regions indicate that one of your copies and one of your match's copies have one identical base at that particular segment. The longer the segment, the more robust the match. But it causes problems. Okay, this is a more up-to-date definition. A match is a person who has a DNA segment on one of their two copies of a specific chromosome that has the same sequence of bases as a DNA segment on one of your two copies of the same corresponding chromosome, and it's known as a half-identical region. Now, when is a match not a match? When it's a false positive. Let's take, say there's a particular segment of DNA on one of your chromosomes, and you compare it to the two chromosomes on the other person. You'll see that this is an identical match. All the green ones here match all the green ones here. It's one of their copies. We don't know whether it's the maternal or paternal, is an identical match for our one. We call this identical by descent, or a true positive. A false positive, on the other hand, and the reason why it's in inverted commas is because I think that is the wrong definition. I don't think false positive captures what we want to say. And this is based on Ann Turner's 2009 JOG article. You could match purely by chance because there's a zigzag of bases between the two copies that actually match completely, identically, the one copy that you have. You could have fuzzy segments where you have an identical region with a false region at the bottom or a false region at the top. Or you could have a compound segment where you have two runs of sequences, but they're not on the same chromosome. All of this will give you a false positive reading, a non-IBD, not identical by descent segment, or an IBS segment, as it's sometimes called, IBS being identical by state. I hate this terminology. because it is so inaccurate. And I'm going to be contentious now and say that this really is very misleading. It doesn't tell us what we really want to know, because how can you call this a false positive when 95% of the segment is an identical by descent segment? How can you call these false positives when it's actually two identical by descent segments in the same segment? So I think we need to really look at this very, very closely. And I think that we are probably misleading ourselves by not being as accurate about these definitions as we could be. So I think we do need to do some work here. And the other big question is, what percentage of each type of false positive do you see? Is this 10%? Is this 70%? Is this 20%? Well, it's going to vary depending on the length of the segments. But that's data that it would be nice to see. Now, John Walden has done some fabulous research, and he's given us these very, very good rule of thumbs that at 8 centimorgans, 50% will be IBD and 50% will be IBS, or non-IBD. At 10 centimorgans, 99% will be true positives and 1% false positive. And at 4 centimorgans, 99% will be false positive. But again, I'd like more information about what exactly are we looking at when we say IBS. Is it a fuzzy segment? Is it a compound segment, or is it just a pure chance segment? So we need more information about this, and it needs to be publicly available. Solutions for non-IBD matches. They're more common as the segments get shorter, but how many are of each kind? Phasing can help identify the false matches, and you can do this on Gedmatch, and it distinguishes between paternal and maternal chromosomes. So whereas the machine doesn't distinguish between what you got from your father and what copy you got from your mother, if you have one of your parents tested, as I have my dad, then you can upload your data and his data to Gedmatch, put them into the machine, and they will come out with a phased chromosome that will tell you exactly what you got from your father and exactly what you got from your mother. That can be very helpful. With the smaller segments, I would put them aside. I don't throw them away completely. Just put them aside unless they're overlapping with someone else's larger segment, and we'll talk about overlapping segments later. So I went to Gedmatch, and because I have my dad's results up there, I was able to look at these unphased results. Again, 1,500 matches, and here's the various proportions of each particular type of cousin. And I looked at my phased paternal chromosome, my phased maternal chromosome, and then I totted the total. What I found when I compared the unphased data to the phased data is that there was overall a 61% reduction in matches. In other words, 60% of my matches were probably significantly non-IBD and therefore essentially useless. That means of the 10,700 that I have there on Ancestry, probably about only 4,000 of them are worthwhile. Clint, question?
What was your cutoff here?
This is 7 centimorgans. 7 centimorgans, but also Gedmatch cuts off at 1,500. So I've just done these analyses in the last couple of days. They're still quite preliminary. I need to go back and really look at these, but I'm throwing them out there because I think this is the type of forum where we throw questions out to the community, because if any of you do this exercise, you will probably find exactly the same thing. So you will want to know what is going on here. I want to know what is going on here, because 61% is actually a lot. Well, Matt Gerke gave me a very, very helpful clue. He said, your dad tested a family finder, you tested family finder, you're actually comparing your phase results to also 23andMe and Ancestry data, which may not have the SNPs in the same position, so it might be out of sequence. Okay, that's a great one. Let me go back and look at family tree DNA only. So my 1,500 matches, unphased matches, fell to 434, which again, 29%, that's in keeping with what we were told the proportion of family tree DNA data in Gedmatch actually is. And I'm still getting a 59% reduction in matches when I'm comparing Family Finder phase data with Family Finder unphased data. And this is what happened, because I wanted to see where were the matches going. Spreadsheet work, 2 o'clock in the morning. These are my third cousins in green. These are the on-phase data moved and shifted in this manner. Most of the green bits, the third cousins, moved into the fourth cousin category. One moved into the fifth cousin category, and three of them moved into the sixth cousin category. Of my fourth cousins, the majority of them stayed in the fourth cousin category, but some moved into the fifth cousin category, and one moved into the sixth cousin category. And you can see that most of my fifth cousins moved into the sixth cousin category, and most of my the sixth cousins here either stayed in the same sixth cousin category. One moved back, strangely, into the fifth cousin category. I'm not sure how that happened. And that suggests a glitch in the process. And the same with my on-phase maternal chromosome. There was a general shift from one generation further back to the next generation further back. The matches on the paternal side seem to be quite erratic, because for some reason I started getting new fifth cousins and sixth cousins that I hadn't got with my on-phase data. And maybe that's something to do with the cutoff of 1,500. But there were no new matches emerging on the maternal side. It could be down to differences between maternal and paternal inheritance. But I also looked at how many disappeared completely. 10% of my third cousins disappeared. Now, I found that very incredible. 37.5% of my fourth cousins disappeared. They didn't end up one generation further down. They dropped off at the seventh cousin. We suddenly shot them back 3 or 4 generations. So I think this is very interesting research, very preliminary, and I think that I'd like to see this replicated and to see what other people's experiences are. But it just goes to raise a question about how trustworthy are the matches that we have. And I think we need to have trust in our DNA data because we don't want to go off on red herrings, we don't want to go down blind alleys. So this is an area that needs further research. Do not discard small segments. Because even though a lot of these small segments will drop off when you phase the data, with my brother and sister, when I compared them with Alan from Australia, Ruby Kathleen's grandson, they inherited 1.1%, 0.6%. My sister had 1.6%, and her daughter had 1.5%. So in this situation, my niece has 2.5 times more DNA shared with Alan than her uncle. So this just goes to show the randomness of genetic inheritance. In terms of the actual longest segment, 38.17 with a prediction of second cousin for my dad, 38.17, 38.17, and a prediction of third cousin for me and my brother. For my sister and her daughter, 23.51 was the largest segment, prediction of third cousin, but she had passed on virtually the entire thing to her daughter. Again, the luck of the draw. My brother, largest segment, 8 centimorgans, prediction fifth cousin. This tells you that fifth cousins could be second cousins, once removed. And all the more reason that you should not get rid of these smaller segments. Don't ignore them completely. And we see this reflected in the chromosome browser. My dad is up here. You can see that I'm in blue. I share that small segment with him. There's 3 of us that share this large segment. There's another 3 of us that share this large segment. But my diminutive brother in yellow only shares very small segments across the chromosome. So you can see that that's why he only comes out as a fifth cousin prediction. Now, I talk about a step-by-step approach to analyzing your autosomal DNA matches. Again, the YouTube video there will take you there specifically. It was a presentation I did at Who Do You Think You Are in London in February. There's a couple of challenges that we face when we do this step-by-step approach. Most importantly, finding other people's trees, because on Ancestry, on family tree DNA, this little icon here gives you a GEDCOM file. This bit here gives you the list of ancestral surnames. My dad has 355 matches. Only 20% of them have a tree on family tree DNA. Only 66% of them have some surnames, some only 2, which isn't great. On if there is no tree, then you can find one, because if you click on the name, you get the profile with a list of incredible features you can search for. You can search for my name, you can search for my email address, you can search for my most distant known ancestors and maybe find my tree on Ancestry. You can also search maybe some of these ancestral names. But by using what you find, you can actually maybe bypass the fact that there's a lack of a tree, and on many occasions I've been able to find that person's tree on Ancestry, and they just haven't bothered putting a Gedmatch up on family tree DNA. So if you can't find a tree, you could always try contacting your match. I mean, it's a little bit archaic. Some don't reply, some won't share, some only give partial information, and many don't have up-to-date trees. So it's really a kind of a lottery. In terms of 23andMe and my 1,343 matches, I'm only sharing with 36% of them. And of the 68% who have been sent an introduction, 11% have accepted, 2% of them accepted but not sharing genomes. I'm not sure what's going on there. 1% declined, and 54% have not even bothered to reply. And of importance, in terms of the family tree on 23andMe, only 7% of my total matches, or 19% of the ones that actually I'm sharing genomes with, have a tree on 23andMe, which is very similar to the 20% on family tree DNA. That is overcome by Ancestry, where everybody has a tree on Ancestry. Some of them are private. Some of them have only 2 people in them. My closest match, for example. And they have this wonderful map feature as well, which shows you locations. And when we're doing our autosomal DNA match assessments, we're looking not just for surnames, we're looking for locations. So this is a very helpful tool. These are my DNA results on Ancestry. I have no shaky leaves. I have no connection DNA-wise with anybody else. That's because I cannot build my tree out to 10 or 12 generations, because I will hit my head on that brick wall at 1800 after about 4 or 5. Now, Ancestry are due to launch in Europe sometime in 2015, we're told. Which countries, we're not entirely sure. Probably the UK and Ireland, yes. France, well, the French love to be difficult, don't they? We love the French in Europe. It's the best place for them. I really like the French. J'écoute les Français, j'aime beaucoup. So the big question is, will France be involved? There's a 15,000 euro fine and a 1 year in prison if you try to do paternity testing in France. Is what we're doing counting as paternity testing? I don't know, but I don't want to try. How long will it take to reach critical mass for Ancestry DNA outside of the US? That's a really important consideration. Will there ever be a chromosome browser? Probably not. Will the new relationship utility make up for it? Possibly. When will it be launched? That's a very interesting question. Will it be a paradigm shift? That's a fascinating question, because our ancestry are going to come up with something that takes our minds away from the chromosome browser completely and makes us think about looking at our DNA in a completely different way. I'd be very interested to hear what people in the audience think about that. So hopefully, I won't talk too long, that there won't be time for questions and a little discussion session afterwards, because it is by discussing amongst ourselves we learn more. I've tested a variety of family members so far. You can see that's me there. There's my dad, my 3 siblings, my niece, my dad's sister, first cousin, second cousin. That's Alan from Australia. And then on my mother's side, I just have my aunt. So my mother's side is quite empty. But I've got a lot of people on my father's side. And that is great because it allows for triangulation. If my dad matches a particular person, and that person matches Alan, then we know that the common ancestor has to lie at or above the level of John Gleason and Anne Gleason, okay? Which is great. It's very helpful for chromosome painting. Now, I would suggest that chromosome painting is of relatively limited utility in my situation, because I have not got any matches from my fishing trip with autosomal DNA. So all the people that I used to construct this chromosome map, I control their kits. I already have access to them. Chromosome mapping would be very useful if you matched with somebody and you didn't have control of their kit, where you actually were able to figure out where your match was, and then you could just demonstrate it here. It also would be potentially useful if we use it in combination with inference. And Tim gave a very good presentation in the last session, which is available on video, about using inference to actually enhance your chromosome mapper. And in order to do inference, you also have to do a little bit of phasing. And David Pike is going to be talking about phasing here 2 lectures after, well, next lecture actually after lunch. So do come along to that. Whitathi, of course, has talked about the phasing of grandparental DNA. It is not for those of a nervous disposition. Avert your eyes now if you are scared. But it can be very, very useful. Jim Austin as well has phased his X chromosome and has been able to deduce certain sections of the chromosome based on his phasing, comparing various siblings. So using siblings can be very, very helpful for phasing your data. Step 4 of my approach would be working with small related triangulated groups. And the aim here is to identify groups who are likely to have the same shared common ancestor. And that means harvesting your in common with matches, seeing who matches who, using the matrix utility, and finding your matching ICW matches, and of course identifying overlapping segments. Well, I liken it to playing a game of cards. You simply assemble your common matches, you identify your triangulated groups, you repeat steps 1 to 3 of the process, which rules out non-contenders among your ancestors using X chromosome, ethnicity, various other activities, and you compare your trees at each stage. It couldn't be more simple. The subtitle for this section of my presentation is Lost in Spreadsheets, Danger, Danger, Will Robinson. Is anybody scared of spreadsheets? Is anyone scared to put up their hand? I kind of balk when I see the amount of extensive work that needs to be done with spreadsheets. And I think with me, because I've got so many other things going on, I forget what I've done. And I get lost, and I have to go back, and I think, oh, I did this already. Oh, okay, that's 5 hours gone. But identifying common matches is based on the idea that my matches will have come maybe half from my father, half from my mother, all things being equal. You know, an average, population average will be half and half. It depends who's tested. It depends what ethnicities have tested. And 1/4 of them would have come from each of my grandparents, and 1/8 of them would have come from each of my great-grandparents. If I compare my matches with my closest match, for example, I find that we both share matches in common. And these are known as our common matches. And the idea here is that there's a common ancestor at or above the level of our shared common ancestor between me and my match. Now, it's more likely to be above, because if it was at the level, then we'd have the same relationship as my match. So if my match is my first cousin, then if it's at that juncture of the common ancestor, they would be first cousins as well. But normally, you get more distant relatives with your match's 2nd, 3rd, 4th, 5th cousins, and so on. But even that's wrong, because it's not just a single common ancestor that all our common matches are related to. It's several. And that's a very important distinction. You're not just looking at your common matches and then going back to a single common ancestor. The common ancestor that you share could be anywhere above the common ancestor you share with your immediate match. And they have a whole family tree above that particular juncture. So a very important distinction. And even that's not right, because it's not a common ancestor at the top, it's a common ancestral couple. And you cannot tell which member of the couple has given you that specific segment of DNA. That's wound its way down. So again, some very important distinctions there. Now, there's also the fly in the ointment. When you're connected to somebody, not just on one parental side, but on both parental sides. Okay, I've got a question. I'm going to give you 4 choices. What is the likelihood that the person that you're sitting beside you are related to by your both your parental lines? Do you think, and it's just the person sitting beside you? Is it 10%, 50%, 80%, or 100%? 10%.
What's the cutoff?
What's the cutoff?
Yeah, what's...
There's no cutoff. 10%. 50%. 80%. 100%. Right, 100% is right. We are all related to everybody else. I'm related to everybody here by my father's line and by my mother's line. I might have to go quite far back, but we'll make a connection somewhere. But not only that, I'm related to all of you by my father's line, on your father's line, and your mother's line. And on my mother's line, I'm related to all of you by your father's line and your mother's line. So I've got 4 connections with every person here. We all share at least 4 common ancestors. Interesting when you conceptualize it in that way. And I'm going to run through this very, very quickly because a lot of this has been dealt with by other people already. We've talked about identifying your common matches, and here are mine, and I set aside potential false positive less than 10 centimorgans. Sue Griffiths has a wonderful blog, and so does Kitty Cooper. So this will be very, very useful for you when you start getting into autosomal DNA matching. Similarly, then, once you've identified them, you can put them into the matrix on family tree DNA and see which of your common matches match each other and can potentially form these small triangulated groups. That's what they're called, small triangulated groups. And those are 4 triangulated groups that fell out of my comparison between my dad and his first cousin, second cousin, Alan, and then a variety of other close matches. And this is confirmed when you look for overlapping segments, and you can see that there is shared segments there. And when we do another 3 individuals, 4, 7, and 8, we still get the same 4 groups of triangulated groups. And this is the old-fashioned way of doing it. And then along came DNA adoption. And what a wonderful crowd of people they are, because they have developed a whole range of tools. Yes, let's give them a round of applause. Rob Wortham, Diane Harmon-Hoog, Karen Korbat, Don Worth, Cece Moore, Messa Ford, Gay Tenenbaum, and specialized sub-teams of individuals who are working hard like Christmas elves to bring us new tools for Christmas. So they have provided us with, for example, Don Worth's ADSD tool, Autosomal DNA Segment Analyzer, and using that tool, I get the same results as I get with using the previous processes, which required identifying common matches, using the matrix to find out who matches who, and then going to the chromosome browser to see who has overlapping segments. All of those 3 activities now in one. And this tool is a wonderful way of introducing you to the more common, to the work that you will have to do with spreadsheets. So we cannot avoid spreadsheets, but the good news is that DNA GEDCOM is making it easy for us by introducing K-works and J-works. And there is a wonderful description from Kitty Cooper about how to use these on her blog. So again, get the handout, click on the link, it'll take you to the page. GenomeMate is also another wonderful way of organizing results. Jim Bartlett is going to be talking to us later on this afternoon about these type of things. So tend Jim's work. Various people have developed different methods. Tim Jansen has developed a method. Jim Bartlett has developed a method. They're all trying to achieve the same thing, so they're all heading in the same direction. Are there possibilities to enrich what we've done so far? And I'm going to talk to you about enrichment strategies, and the idea here is to boost the numbers in your triangulated groups. And this is going to be particularly important for people with Irish ancestry, because we're told go for the low-hanging fruit first of all. And the low-hanging fruit would be those close matches that you have, and hopefully you can make that connection much more easier with the distant ones. So coming back to my diagram of Dad, his first cousin Betty, and Alan from Australia, and looking at the triangulated groups we identified previously, when I compare dad with his first cousin. We know that because they match both dad and his first cousin, the common ancestor has to be somewhere at or above the level of these two people here. And these are the four groups, the triangulated groups identified. There's dad there. Because nobody matches with Alan, I'm inclined to think that it's more likely that most of these triangulated groups have a common ancestor on this side of the family tree. But it could be that they have a common ancestor on this side. It's just that the DNA that Betty and Dad share has not trickled down to Alan. So you can't rule it out completely. And then there's the last of these triangulated groups. The problem is, as I try to reach for this low-hanging fruit, I bang my head against my low-hanging brick wall. And that is a big problem, because there are 2 generations further back, and it's going to be very difficult to get beyond that brick wall if there are no records. So what can you do? Are there ways that we can boost or enrich the numbers in these triangulated groups in the hope of finding the one person with the family Bible that everybody can say, oh, well, because we're related to you genetically, we can go back and piggyback with you with the family Bible and jump back into the 1700s and the 1600s. Every Irishman's dream. That's a $64,000 question. And again, I come back to Jim Addison, who's got an excellent blog about non-genetic relatives in the DNA database. Has anybody read this? No? Really? Have a really good read. This is a really good read, okay? I hear you saying, but Spock, non-genetic relatives in a DNA database. What do you mean? And my answer is, they're cousins, Jim, but not as we know them. And Jim's suggestion really struck a chord with me, particularly when I found out how little information that Dad and his first cousin share with their mutual second cousin, Alan, in Australia. Dad is in blue, and Betty is in orange, and the segments that they each share with their second cousin are not overlapping at all. That's at 10 centimorgans. Even at 1 centimorgan, there are 9 minor overlapping segments. And this got me thinking and said, well, hold on, if there isn't that degree of overlap between them on these segments, then the in common with matches that Alan shares with Dad may be completely different to the ones Alan shares with Betty. So I looked at Alan and Dad's in common with matches. There were 3 pages of them, 18 matches altogether once you take out my immediate family. And when we compared Alan and Betty, there were 8 pages. 8 pages of common matches, 73 of them altogether. What do you think the overlap was here in the middle? Have a guess. 2?
0.
3? 0? 1? None. None. Indicating that Alan and Betty's 73 matches are probably Dad's non-genetic cousins, because we know that they are related. And similarly, Alan and Dad's 18 matches are probably Betty's non-genetic cousins. So we have got 91 matches between Alan and Betty, some of whom Dad is genetically related to, but the majority he's not genetically related to at all. Now I say probably, because the fly in the ointment here, of course, is, are Alan and Betty related by another parental line? And Betty was a difficult child. She's 80, she still is. She has ended up on my dad's mother's side of the family when she comes from my dad's father's side of the family. So I'm outraged. And I'm going to give her a stern talking to when I see her next. But this is very interesting. How do we, you see, I only found these non-genetic matches because I control all the kits. I don't control kits 3, 5, 6, or 7 and 8, or 4. So what do I need to see? I actually need to see everything that I've done going through the process so far. I need to see an in common with match list for each person in each triangulated group compared to every other person in each triangulated group. I need to do that matrix analysis of who matches who. I need to look at the overlapping segments for each person in the group compared to each other person in the group. And can any of the additional triangulated groups thus generated be linked to any of the existing triangulated groups to make a mega group, a triangulated mega group? That is the question. And can it be done? Well, how do I access the kids to actually do this kind of analysis? Do I ask them for their username and password? Please send me your username and password. Sorry, do I ask them to send me their income with matches for each comparison? Oh, and while you're at it, can you send me all your overlapping segments as well and just let me know? It's only 2 hours of work. I'm not asking a lot. Do I start a family finder project on Family Tree DNA and ask them all to join? All 360 of my matches? Do I check if they're all on Gedmatch or 23andMe, which does allow this kind of comparison? And will it work? Because the issue of contamination is still going to be there. And can we automate it? So Betty and Alan and anyone else may be related via their other parental line, and this could give us a contaminated mixture of maternal and paternal matches. Now, I haven't any experience of doing this type of work, but I throw it out to the group, and Rob has his hand up, and he's going to say it's possible, and they're doing it now in Bethesda.
Yes.
Excellent. How would you get?
What you do is you go on 23andMe, the 23andMe tab, enter your username and password. At the bottom, I haven't looked at it for a while, but at the bottom you have your match name. You put the match name in there, and it will run your match against all of the people that you also share with, and it will compare your match to all of your other matches and give you a spreadsheet just like your normal spreadsheet would be.
You can if you're on 23andMe, and
on 23andMe, also anybody you share with, you can go into countries of ancestry, click on the bottom, and you get a list of all the people that are in the countries and ancestry database that your match shares. In addition, Ancestry&Me has told me that I can now, and I just went on it last night after talking to the lady, I can now go on Ancestry and send out a sharing invitation to everybody in my DNA database, and if they agree to it, I get to look at all of their matches, and I can then put them in and play around. So it's coming.
Fabulous. Okay, so it is possible with 23andMe, just to repeat so that everybody hears. With 23andMe, you can compare every one of your matches against every other one of your matches. On Ancestry DNA, you'll be able to do the same kind of thing, and you'll also be able to get a list of their matches as well. So we're heading in the right direction, but you're either on 23andMe or you're on Ancestry, and now you're jumping between the two, trying to, it'd be great if we just had a button that we could push, and it did everything for us. So hopefully some of the developers out there will be working on a tool that will be able to take advantage of what's happening at Ancestry, what's happening at 23andMe, and allow us to put it all together into one big group. So yes, there are challenges. Sorry, Rob, yes?
That's if you're using Jeff Snavely's tool, you already have the ability to download all your ancestors. The new GWorks tool, when you upload it, will let you see how your matches match each other.
Great.
That will be one of the features that you'll be able to do. It's in the common with, at least with the trees.
So Jeff Snavely tool will allow you to pull a lot of this stuff down, and GWorks will allow you to compare the getcoms across all of your matches that you pull down. So yes, there are challenges, obstacles, and hurdles, and this is one of my last few slides. It ain't easy. Close matches are few. People don't share their trees. The 1800 brick wall in Ireland and elsewhere is a problem. African American research, mid-1800s, you hit the same kind of brick wall. What other countries have a brick wall around about that time? Sweden? Ashkenazi? Norway? So there's quite a few people, and there's places in the US as well where you will hit that brick wall mid-1800s. When is a match not a match is still such a basic question that we really need to spend some proper time identifying that. Chromosome mapping plus inference can be very, very useful. We need more people doing it to teach the rest of us how to do it. Getting lost in spreadsheets is hopefully going to be a thing of the past. Won't it be great in 5 years' time when people say spreadsheet? I haven't used one of those since 2014. The need for enrichment strategies to boost numbers in the triangulated groups is important. We can overcome some of these obstacles. We maybe have fewer problems as experience grows. There may be fewer problems as more people test, especially outside of the US. And there's a need for ongoing dialogue and cross-fertilization, which I think this conference has magnificently achieved. So a big thank you to Tim Jansen and Cece Moore for doing such a wonderful job organizing this. The secrets to success, as you've heard before, start with your closest matches, share your tree, develop a relationship with your matches, not just a one-line email. Keep track of what you've done. And we have Don's tool and now the spreadsheets with K-Works and J-Works. YDNA projects may be a useful anchor, and that really needs further exploration. Hopefully this time next year we'll have some people presenting on the autosomal DNA in their YDNA project. What does it tell us? It could be very useful. We need to create more tools, we need to automate more tools, and commercial companies need to incorporate them into the service they provide to their customers, us. Now, good news is that people are testing outside of the US. And back to our past in October in Ireland, we sold 99 kits. Half of them were Family Finder, 40% of them were YDNA 37s, a small proportion were mitochondrial. And then in London, at Who Do You Think You Are, in February, we ran out of kits. We ran out of DNA kits. We sold out on the Sunday afternoon at 3 o'clock, and we just hung around for 2 hours patting each other on the back. And 41% of them were Family Finder, about a third of them were YDNA, and a third were mitochondrial DNA. So people outside the US are testing. It's great for those of you that have British and Irish ancestry. Hopefully France will become less French in due course. We'll see some people from France testing as well, parce que nous aimons beaucoup les Français. And Genetic Genealogy Ireland is happening for a second year in a row, and we have got a wide variety, we've got a full pack schedule. If you're worried about the airfare to Dublin, don't, because it's going to cost you $28 for all 3 days. So the cost of $28 for all 3 days of the conference will offset the price of the airfare. It was worth a shot. But we've got some great discussions, especially about how Irish DNA is linking to the ancient animals. We have Spencer Wells coming over for the keynote address from the National Geographic Project. We have Irish Caribbean DNA. We have ancient genealogies. We have plague. So come over and see what plague is all about, the DNA of plague. Solving adoption mysteries in your family tree is going to be a very, very big topic. We also have Daniel Crouch from the People of the British Isles Project talking, so he will be able to answer questions about when that autosomal DNA will be available. We've got Patrick Guinness, yes, he might give you a free one, talking about Nile of the 9 hostages. And we have Professor Catherine Swift from the University of Limerick talking about Brian Boru, because it is the millennium of the Battle of Clontarf, when we beat those Vikings and kicked them out. Well, actually, there were Vikings on both sides, so don't believe everything you see. And then hopefully we're going to have something also to commemorate the centenary of the start of World War I. And the fact that DNA is not collected routinely on the battlefields where they are continuing to find human remains to this day, when they're farming, when they're doing road building works. So hopefully we will be able to put a little bit of pressure on the powers that be to make DNA collection from these human remains more systematic, and that way we'll be able to identify more people. So we'll hopefully be having somebody that talks about that particular issue. So if you do come to Ireland, it would be great to see you there. And thank you very much for your kind attention. I will leave you there. Yeah, sure. Now, Rachel has a couple of announcements which we'll make
One
now.
of them, I just want to remind you, we do have the Missouri room still open. A Family Finder test today is $89 on sale for those that might want to get that. And they have all the other tests also on sale. I don't know if the representatives from, there is someone from Ancestry there and 23andMe. I didn't see anyone this morning, but be sure and look at the Missouri room. If you haven't checked out yet, if you're staying here, please do so. And your bags can be stored in the Catherine room right across from the registration tables. So thank you, Maurice.
Thank you. If anyone has any questions, I'm happy to answer them.
Hi, I've got a quick question.
Sure.
I'm actually adopted.
Oh, right, okay.
And I've and basically what
Yeah, so, I think
how far out
We're inviting people to join the family finder club. Cousin Betty joined. But hopefully in the next couple of
But how does that play out as far as the what can I learn, about my ancestry based on given
they were included in people's with child projects. There's also the Oceanography project on the family tree. There's also the Scots-Irish project. Yeah, so many Scottish. That's Barry McLean. Ulster Heritage, Scots-Irish, FTDNA Scots-Irish. And they'll also look at Halloween and Northern Ireland family history studies. So do search for Halloween. Recently sold 45 kits. So one of your ancestors might be there.
Okay, that's great. And what will I learn? What will I actually learn? What will we learn?
What they want to segregate the average population into 39 distinct genetic clusters. So what they'll do is take your autosomal DNA, see if your autosomal DNA matches one or several of those clusters. If it does, it turns out actually 10% of your DNA matches your own, suggesting that 10% of your ancestors have
Right.
which is absolutely a fantastic way of narrowing down where to start your own.
Right. Well, some of that is already happening on the YDNA project. It's family tree DNA.
Now they're moving from DNA to
Well, that's right.
hopefully they'll go like
And then I'm wondering what the link is. Again, back to the original question. The linkage between the YDNA.
Yeah, again, research that needs to be done. Glad we were able to throw
Anyway,
it out there.
thank you very much.
Because it's more complex to use access and other software than it is to use spreadsheets.
Is it more powerful? You can put any table together in one?
Probably. I'm wondering if Angie is around. No, she's not.
But it's more complicated.
Okay.
Yeah.
So it's just learning the software?
Most people already use Excel to
set
track
up.
something.
Exactly.
Does anybody use database?
I do. Well, I mean, I have in the past, but I don't use it for this.
Yeah.
I thought about it, but
Yeah.
it's too complicated.
I
to
asked
set
about
up.
access, and
But it's very
for Chris
complicated.
Pomeroy, for example, the Pomeroy project, he said if he was to do it all again, he would have used a database because he had no concept at the beginning how much work was going to be involved. I suppose I just do. So he would, if you can use an access database or some sort of database, I'll definitely use it, but it's not going to be everybody's cup of tea. So
You need technical children.
you need, we
They can set it up.
The more the better. The more the better.
And then make it free and available.
Oh, of course. I'm
Don't
serious.
set it up in France for God's sake.
No.
I have a question, well, I have a question where to find things.
Okay.
This is my husband making a half Irish. Supposedly born in Ancestor, registry, is a tree, and you go back from Paris. DNA seems to prove that way. There's some action parents and the United States. Can't find anything in Are they willing to test?
They are, and in actual fact, I'm not seeing anybody here, but Linda is coming over in October to Dublin to have a swab meeting for family tree DNA stand. It's a group of dedicated ISOL volunteers who are traveling around the world and helping family tree DNA set up their systems. Belmullet Male. Okay, Belmullet is on the far west coast of Ireland. You have to cross a bridge to get there. It's very, very difficult. When I did that analysis of the kits we sold last year, everybody was centered around Dublin.
Yeah,
there was maybe one person from each of the other counties in Ireland. So we have a DNA outreach program, which I've started. So now myself, Tyrone Bowes, and Jared Corkin, who are all Irish, and travel around Ireland from time to time talking. We will carry kits with us, and we will try and swap people at those events. So, for example, we were talking in Burr, in the Midlands yesterday. It's in County Westmeath, County Burr, County. Yes, I think you're right. And it is, we got 10 kits. Went up to Ballymena, 45 kits.
Are you selling them or
Selling
free?
them.
Are you
Oh,
selling them?
Oh, yeah, we're selling them. So you have the special discount price.
If I'm able to come next year, I'll take some down to Cork and Care.
Oh, do? No, that would be absolutely fine. And Paul Byrne, who's 85 and runs the Byrne Project, collected 50 kits traveling around Leinster last year. And some the Main Island Project from Portland, Maine, they went out and they approached farmers in their fields.
And what were the
They said, fine, yeah, you're from the Maine Gedmatch, you're from Florence.
That's a bit different than us as an American coming over there and asking you to swap.
Well, no, but these were Maine people from Maine. Yeah,
Oh,
exactly.
Remember the name?
Yeah, people with the British Isles Project is going to make their data publicly available, and they said it will be in the next 12 to 18 months.
You're talking about something else.
Over the Irish ones?
You talked about an Irish, then you talked about another English, but it was after you talked about the 12 to 18 months.
It wasn't the British Isles, only the UK.
The Irish ones. Yeah. And Wales as well. Yeah.
But before that, it became
For now, but there's a lot of French people that are coming over and having the test done outside France. Well, yeah, you can leave the country, they do the test and go back in and they go, you know where you've been. But anyway, so in the next 4 or 5 years it'll be Ireland. We'll be able to do the autosomal comparison and the biogeographical analysis.
you can't really increase
There are YDNA projects for non-kids. There are YDNA projects for non-kids.
The SARS database, I don't think so.
Well, supposedly, and they went to Wales, it's very, see, there's Jim Barrett, who's administrating
Jim Barrett, it's me.
Okay, and supposedly they might be related.
Oh, sure.
Well, so far,
Slide on it.
so far,
You showed Connie Farrell